Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about regression lines. All right, so a regression line is a line that models how a response variable, y, changes as an explanatory variable, x, changes. Regression lines are expressed in the form y hat equals a plus bx, where y hat is pronounced y hat, is the predicted value for y for a given value of x. Extrapolation is what happens if the use of the regression line for predictions outside of the interval of the x values is used to obtain the line. The further we extrapolate, the less reliable our predictions. So if I try to, if I only have data for when x is 1 up until x is 10, and then we use that model, the regression line, to make a prediction when x is 20, well, my highest value is only 10, so 20 is way far from 10, so that's not going to be a super reliable. A lot of things could happen. All right, and that's called extrapolation. All right, residuals is the difference between an actual value of y and the value of y predicted by the regression line. That is, the residual equals actual y minus predicted y, or y minus y hat. The y-intercept, which is a in our equation, is the predicted value of y when x equals 0. The slope, which is b in our equation, is the amount the predicted value of y changes when x increases by 1 unit. All right, making predictions and interpretations. Do taller people tend to jump higher? Student researcher Haley, Jeff, and Nathan investigated this question by measuring the height in inches and standing vertical leap of 74 different students. Here is a scatter plot of the data along with the equation of the regression line y hat equals negative 31.20 plus 0.70x, where y equals the vertical jump in inches and x equals height in inches. Predict the vertical jump of a student who is 68 inches tall. All right, so to do this, I'm going to plug 68 in for x, because x stands for their height, into our equation and try to find y hat. So I'm doing negative 31.2 plus 0.7 times 68. That gives me 16.4 inches. All right, a student who is 68 inches tall has a predicted vertical jump of 16.4 inches. All right, interpret the slope of the regression line. So it's a plus bx. B is my slope, so the 0.7 is my slope. So the predicted vertical jump in inches increases by 0.70 for each increase of 1 inch in height on average. Okay. Or you could word this you could put it in the opposite direction. So you could say for each additional increase of height in 1 inch, the predicted vertical jump increases by 0.7 inches. That would work as well. Does the value of the y-intercept have meaning in this context? If so, interpret the y-intercept. If not, explain why. So my y-intercept is a, the negative 31.2. So the y-intercept does not have meaning because it's impossible for somebody to have a negative vertical jump. All right, calculating and interpreting residual. One study measured the density of corallites in 16 randomly selected coral colonies during a scuba dive. Here is a scatter plot of these data along with the regression line y hat equals 176.61 minus 7.59x, where x equals the depth and y equals the corallite density. Calculate the residual for a coral colony with a density of 78 corallites per 100 centimeters squared at a depth of 10 meters. Okay, so what they gave us is when the depth is 10 meters, their density is 78 corallites per 100 centimeters. So I have like the actual value. We want the residual, so I'm going to have to find the predicted y value with a depth of 10 meters and then subtract that from the actual y value. All right, so I'm plugging 10 in, my depth in meters for x, and that gives me a predicted y value, or correlate density of 100.71 centimeters cubed. So my residual is the actual y minus the predicted y. Well, my actual y was 78. My predicted y was 100.71. When I subtract those, I get negative 22.71. So that my residual is negative. If I interpret that residual, we would say this coral colony contained 22.71 fewer corallites per 100 centimeters squared than the number predicted by the regression line with x equaling depth. Okay, so it was, our prediction was an overestimate, and our actual value was less than the predicted. All right, go Seahawks.